Okay, so now that we're on page 13, let's go through these. It asks us to determine the domain and range for the following graphed functions. Now this is pretty simple because the graph is given. Down the road, we won't be giving you the graph and we'll just give you this equation. But for now, we can use our graph to determine what the domain and range are, which is super helpful. So here we have a parabola, and we see that the vertex for this parabola is at 3, -4. If we zoom in here, we can also see that there are these little arrows, which indicates that this parabola is going to get taller and taller, higher and higher, but it will also get wider and wider. And eventually, the x values will continue to stretch more towards the left as well as to the right. So when we're talking about our domain, remember we're talking about the x values, how wide our x values can go. And for a parabola that's for this parabola here, we know that it'll go wider and wider in both directions. So our domain notation for this is x belongs to the set of all real numbers. It'll eventually become everything. For the range, we need to take a look at what possible y values this parabola will have. And so it is going to reach a bottom of -4, but then continue to go up, and it'll get taller and taller and higher and higher. So the range for this is f of x belongs to the set of real numbers, but such that it will only be greater or equal to -4. -4 is the bottom, and it'll go higher and above that. So our range is written using this notation. F of x belongs to a set of real numbers such that f of x is greater or equal to -4. So that's our first question. We have our second one here. And notice that we have a square root showing up in the equation. So in this case, let's go here. So we have this square root symbol here, and the graph is also given. And if we zoom in, we can see that there is a little arrow on one end, but on this end, there isn't. It's just a firm dot, which matches our parent, where normally it would look kind of like starting at 0, 0, and it would branch off from there. So let's take a look at what the domain and range are for this graph. So domain, again, is how left and right it will go. And if we kind of sketch down here, then it kind of looks like that it would be starting at -2 and go right from there. So our domain is XER. X belongs to the set of real numbers. It can be every single in-between dot, like -2, -1.5, -1.44449. It'll all be these in-between dots, but there is a limit. X will only be greater or equal to -2. It will never be smaller than -2. So it'll never be in this zone over here. So that helps us figure out what our domain is. Now our range is similar. Our range, it starts off here. It starts off at -6, and our graph will get taller and higher than -6, but will never go below -6. So for that case, range is f of x belongs to the set of real numbers such that f of x is going to be greater or equal to -6. Never smaller than -6. So those are the domain and range for the second question here. Okay, now let's scroll down over to this one. We have the absolute values showing up, and we also have the graph, which is super helpful. And if you zoom in again, we have a point at the top there, and we also have little arrowheads at the bottom, indicating that this graph will continue to get wider and wider and lower and lower. So domain, I think hopefully that's clear, that the domain will eventually go forever to negative infinity and also to positive infinity. So the domain for this is x belongs to the set of all real numbers. No limits, it can be anything. For the range though, we do have a limitation here. The limitation is that our y values can be 5 or lower, but never higher than -5. So how do we notate that? F of x belongs to the set of real numbers such that f of x is only going to be smaller or equal to 5. So be careful with the direction of your Pac-Man. The f of x will be smaller or equal to 5, but never greater than 5. Last one here, we have this function, and notice that we have an x showing up in the denominator. And so that is a reciprocal function. And we have the graph here that will help us with a few things. It's not ideal though, because take a look if we zoom in at our asymptotes. Our asymptotes are happening at approximately, like not exactly at 1. So let's ballpark that this would be approximately happening at -0.5. Just a guess, a guesstimate. In terms of our y asymptote here though, that's pretty clear that our asymptote is y equals 4. So our graph will never be 4, but it can get really, really close to 4. And our x values would get really, really close to -0.5, but never actually become 0.75. So those asymptotes just become our restrictions. X could be any other number except for positive 0.75. And our y values can be anything it wants to be. It could be positive infinity, negative infinity. It just can't equal 4. So our domain and range for reciprocal functions are just literally, it can be anything except for the asymptote, the x asymptote. And for our range, similarly, f of x can be anything except for f of x can't be 4. So those are our restrictions, and that's how we notate the domain and range for reciprocal functions. So that's pretty much the main part of our lesson. On Tuesday, Miss Jacobs is going to be, on Wednesday, period 2, Miss Jacobs is going to be talking about page 14 and go through that with you. If you want to wait for Miss Jacob to explain page 14, then you can definitely stop this video at this point and start doing your homework. But if you want to continue,